I'm Sawood from the Internet Archive. I'm the research lead of the Wayback Machine. Presenting today, utilizing large language models for semantic search and summarization of international television news archives. That's a mouthful. Internet Archive has all sorts of media types like books and web, audio, video, and one of those media types is TV. So if you go to archive.org/TV, you will see a collection or a collection of collections there. That is where all the TV archive is stored. Somewhere in the middle of the page, there is a paragraph that says, latest news from the last hour. Because the amount of TV news we archive or TV data that we archive is so enormous, there should be a way to make sense of it. And it's not easy for people to consume everything at once, right? So that's one little way that is also using AI, and it gets data from stickers or chyrons from TV screen to generate that text here. But that's a work of another colleague of ours, and there will be a talk for another day. So that's one way how we make sense of these large collections. If you go to Internet Archive headquarters in San Francisco, you will see there are a bunch of TV tuners that are streaming TV data and archiving those. And we chunk them in smaller pieces like half an hour, 1 hour, or 2 hours pieces, however long the programs are from these TV news, right? Our project, one of our collaborators or partners at GDELT project, they basically take some of that data and they process it through Google APIs to extract transcripts and translations out of those audios. So transcripts generally happen in the original language, and we have TV archive in many international languages, such as Ukrainian, Russian, Iranian, to name a few. So the transcript will be in the language that maybe English-speaking people might not understand. So it also goes through translation process. Now there's a blog post on GDELT project that basically describes how to download that data from them, the transcripts and translations specifically. But if you download, that's a lot of data. For one TV channel, for the whole day worth of transcripts or translations, it's a lot for any person to consume. So you need to summarize that. There is another way of understanding what's going on around the world, basically. And that's the project that I'm talking about here. So once you select a TV channel and a date, you get the inventory of all the programs there, right? The stop time, start time, any descriptions, program title, if there is present any, and a bunch of other attributes. And there is an ID column here, which basically tells this is the identifier how you get the recordings from the Internet Archive. So with this data available, we can loop through it and get all the transcripts of all these inventories. So to get the daily summaries, we built a system initially, and what we did is basically we get like all these translations for 1 day worth of one TV channel data. That's a lot of text. And we asked large language model, give us like top 10 news headlines with summary in these articles in Markdown format. And we did get like 10 headlines with summaries. But the way it was working, the data could not fit in the prompt itself. So it was kind of we were doing like piece by piece, like first sending like say 1,000 tokens or something with this question, and we get a response. And next time we say, hey, but there was some text that we sent and we got this answer. Now here's some more text. Refine this answer in the light of this extra text that we are sending. And we were doing it iteratively again and again and again until the end of the transcript. And then finally, we'll get like a refined answer. Now, that has a bunch of problems. It has poor recall. Some of the material that was discussed early in the transcript might have been lost in this repeated refinement process. It would hallucinate. There was a lot of token usage because you have to go through the whole transcript. And with sequential processing, it was taking a lot of time. And then you cannot really say if it is telling a headline where exactly it is fetching from, like where can I go back and reference it. So we started working on another design of the system. And the archiving TV and transcribing and translation, those pieces were in place as they were. But then we introduced chunking, clustering, summarization, and rendering. Okay, so we'll talk about this. So when you get these transcripts, they are basically the captions. They come with like a start time, an end time, and the associated text. And those pieces are generally very small, like 3-second, 4-second pieces, not complete sentences either. So we have to combine them to make sense of it. And we wanted to have pieces that are large enough that there is at least one concept discussed in there, maybe like a paragraph worth of text, but not too large that like 20 different things were talked about. So this is how kind of finding the sweet spot and where these pieces, when they put together with a new boundary of start and end time and all the text that comes together. So, so then these pieces will be treated as individual documents. And the problem that we had some things like, what would be the sweet spot? Like, what is the right length? How to align temporally. So for example, transcription and then translation, it generally loses the temporal. Someone in the recording is saying something else, and the translation is talking about like, a matter that is like 10 seconds later or earlier or something like that. And then sentence boundaries, because these, you are just piecing it by time, you don't really know where the sentence starts and when it ends. So one way to deal with that is like to take a little bit extra before and after text, and then prune any incomplete sentences from beginning and end. So that's one way to deal with that. Some of these chunks will be empty. There is like silence, nothing going on, or there's like music playing or something. So with those pieces identified, like slightly larger pieces, we gone from, say, like many 3-second pieces to many 30-second pieces, or many 1-second pieces, or something like that. And then we started vectorizing each piece. So now in the vector space, we have a place for all of these pieces. And vectors or word embeddings are generally like very well-known pieces in the LLM world. But the idea is, say I have 2 books, and someone asks me how similar or different these books are. This is a vague question. I don't know on what ground I'm going to talk about the similarity or differences in these books. Like, are you talking about the size, thickness, number of pages, the color of the book, or the language, the topic? Don't know. So maybe all these features, if we give scores to all these features, and each book now sits in this hyperdimension where, depending on these scores on these various dimensions, and then we can talk about their distances in this hyperdimension. That's one way to talk about similarities. And that representation of multiple dimensions in terms of numbers that associate with a word or concept or anything, that is what embedding or vectors in a sense. So there are a few things to consider when you are vectorizing these kind of pieces. Like, are you going to use bag of words or transformer models to get the vectors? Bag of word will be simpler to do. It's like you pre-calculate vector representations of all the tokens, and then you just basically get the frequency of words in a document and calculate the mean of all those vectors. But it loses the semantics of sentence. For example, if I'm saying I'm presenting versus am I presenting, these are 2 different things. One is a question, the other one is kind of a statement. But the bag of word will give the same kind of average for that. But then transformer models, they understand sentence properly, in which context they are used. They are generally costly to run because they would require GPUs and all. Then do you want to use like a monolingual model or multilingual? what happens when there is a new vocabulary shows up, and especially in news, there are a lot of new terminologies show up that are like, if your model was trained like 10 years ago or 5 years ago, many new terms showed up that were not part of your model before. So how to deal with that? How to deal with stop words. And sometimes you can use TF-IDFs, and or you can use like a localized stop word based on all these documents that you have. Consider them as a collection, just 1 day worth of transcripts, and that's how we did it, basically. So once you vectorize them, now you cluster them, okay? So the idea is if there is a news-worthy topic that is going on TV, they will perhaps talk about it multiple times throughout the day. And so there will be many different pieces of text that will be together in that vector space. Identify those clusters, and then select one representative sample or a few representative samples from each cluster. That's what we are doing here. And I mean, there's like things to think about is like what kind of clustering algorithm to use, how are you going to sample from each cluster, and sometimes you use like these projection techniques to kind of visually see what's going on. Now we got one piece from each cluster, and we dropped down the usage of LLM from like 2 orders of magnitude by doing this. And now you put like text of one particular piece there in the prompt, and then I said, create the most prominent headline from the text enclosed in 3 backticks above, described in a paragraph, assign a category to it, determine whether it is an international interest, and stuff like that. And then I also gave an example of a JSON block and said, give me answers like that. LLMs do a good job of that. So we get some metadata that we stored in the piece itself when we were kind of breaking apart those transcripts. And we got some metadata from these LLMs, and we combine those. That becomes like the new summary object. And then we can run through all the representative samples from each cluster, and you get an inventory of all these headlines from there. Now, some of them will be ads, like in this case, there is a kind of, forget the inconvenience of sleeping on sofa beds with whatever, right? So that's like, because those ads are repeated many times as well, so you need to identify those and exclude those from our rendition if you want to. And then we will a UI around that where you can have like a bunch of configuration parameters that you can adjust, and it will render stuff for you. These are interactive. You can click on those videos. Because we know the start and end time and ID of those pieces, we can play it back from the Internet Archive. In fact, you can also go directly to the Internet Archive at a very specific place, and you see another UI for that. So now that you have already done this kind of daily summarization, we can just put those pieces that we created, say, vectors for, into a vector database. And now it will become like a semantic search system. We can ask questions, and we'll find relevant pieces from this metadata, and that will, you bring it out. You can serve it with the same UI or whatever UI you want to put in front of it. But you can also, if you don't want to go through like 20 different results, you can pass it to another LLM and let it summarize the result for you, whatever was the search response that you got. So that's basically a RAG implementation. So with that, basically the whole process now goes from archive TV, transcribe it, translate it, make chunks, cluster them, summarize them, and then render them. So this is the whole pipeline or process that we are using. The code base is available on GitHub, and there is a demo deployment that you can go and actually see it in action. It's not in production ready yet, but it's working. The pieces that are missing are like we did not do proper evaluation of our work yet. There is another challenge, like it doesn't really work very well across languages because some of the LLMs we use, they might not know all the languages that we are getting transcripts from. So it becomes a little, sometimes it will summarize in English, sometimes it will try to summarize in the original language. Maybe a little bit of refinement in the prompt itself can improve that. So I'll be ready to take any questions.